This is a continuation of my Is the King in Check challenge videos. Now, something awesome. Somebody's created a formalized version of the challenge that I did. So I did it as a regular expression in a one-liner, which is a kind of an additional constraint that I imposed upon myself when doing the Is the King in Check challenge. If you want to see that video, by the way, I'll put it in the description. I would recommend you watch that first before watching this video. But yeah, somebody's created a one-line task, Is the King in Check, and it's been created by Torkel. I'm not sure if I'm pronouncing that correctly, but yeah, I've submitted my one-liner solution. So quite cool to see all the different solutions that people have come up with for this challenge, doing it all on one line. I'm going to have to go through these in detail, but it's really awesome to see. But anyway, going back to the original solution or the original challenge, there's a few things that I wanted to clarify based on the comments on my previous video. And towards the end of the video, I've got a couple of things. So I've got a new version that I can share with you that is slightly shorter. And I also have an entirely new approach to this problem, which uses a kind of a crazy new approach using maths and trigonometry and stuff like that to calculate express the pieces on the board in a different, more mathematical way, and then filtering for the things that we need and finding the pieces that give the king check in a mathematical manner rather than using a regex. So I'll share a little teaser of that, and I'll probably do a dedicated video on that. There are a lot of questions around line of sight and how my solution wouldn't work if there was a piece in the way of, for example, this bishop that is attacking the king. But it actually does work, but it's not clear because there's a space right here that is easy to miss. And that space is quite crucial because if we flip back to the question, now the grid that we get is a two-dimensional array. Now for spaces on the board, as in positions where there are not a piece, there is a space in the string, in the array that we get. So for that reason, when we're matching multiple rows, essentially, with this repetition of this grouped section here, we must match a space, as in a literal space character, between the bishop and the king. Now, if the king was over here, we'd, of course, with this repetition of this group, have to match 1, 2, 3 space characters in the source string. This also touches on another question that was asked quite a lot. And for the same reason, it's quite reasonable, people asking the question, hey, this looks like you could just use the plus if the whole point of this part of the regular expression is to have one or many of the repeated section, then that's precisely what a plus is for. And of course, they're absolutely correct, but it does, again, miss the slightly unclear detail that there is, in fact, a space here. So you can't do this because you need to have that subtle difference to ensure that you match the space to ensure the line of sight between the bishop and the king. Of course, this applies equally to other directions, not just diagonally, but in this case where you've got the rook attacking the king, it's the exact same concept. You need this space matching on these squares so that if there was a bishop here, this regular expression would no longer match because it would try to match a space in this location of this bishop, and it wouldn't match because it's not a literal space character. Now, another thing that came up was mentioning the amount of padding that I was using. So I started out with 8, and I said, well, actually it works with 7. Some people then went further to say, well, why do you need 7? you can use less. And they're right. You can. So when I first implemented or started playing with the solution, I didn't have an exact idea of what I was going to be doing. I just knew I wanted to have some padding. And I didn't know how the final solution would be, so I just added more than I thought would be necessary. And I guess I settled on 7 because I figured because of a diagonal, it would at least always miss the board. Therefore, it would be fine. But yeah, everyone that's pointing out that you don't need 7, absolutely correct. You can have as few as 2, in fact. You do need 2, though. There's some people that suggested that you could get away with 1. Now, they are correct for all pieces except for knights. Now, of course, when you're matching, like on a diagonal, let's say, hitting one padding character is enough to break the chain, and that's sufficient. But for knights, because we were using, because they jump 2 squares, and we're using an explicit kind of offset value, for that reason, you have to have at least 2, because knights would effectively jump over a single line of padding. There were others that said that with features like look ahead, look behind, stuff like that, you could probably get away with no padding at all. If you, for example, tried to match, say, multiples of 8 number of characters to get back to the start of the entire string, and therefore you're not crossing like an edge boundary. That's a really clever idea, and I didn't do that. I suppose we could explore it, but my gut feel is that it might end up making it a lot more complicated, and it may not be as short and concise. But it's a perfectly valid suggestion, and I welcome anyone to see if they can do it. I'd love to see that. Let me know in the comments if you manage to achieve it. Now, some others came up with the idea to both flip the board horizontally and vertically. And in doing so, you can cut down some of the repetition that I've got in the regular expressions that I've got. Because if you remember, so I've got, like here, for example, I'm checking for a rook or a queen and then a king, so matching in one direction, and then I've got the king being matched with some characters, and then the piece that's giving the check afterwards. So yeah, they're absolutely correct. This concept of flipping the board horizontally could also work in the vertical direction as well. I did play with this before I did my original video, in fact, but alas, the code that it took to perform the operation of flipping in the vertical direction caused the solution to be longer, because the amount that you saved in the regex was less than the code that it took to actually flip the board. At least when I first tried it. Maybe that's a hint as to the new shorter solution that I've got. In fact, we can quickly look at the solution. In fact, this is one of the ideas I came up with before I did the first video. Maybe that's not the best one to start with, actually. Let's look. Yeah, here we go. So yeah, this is approximately similar to the first one, but you've got this extra section where so this would be the string that is constructed in the way that we did based on the first video. And then what I'm doing is I'm taking that entire string and then I'm reversing that, which kind of, if you think about it, flips it in the vertical direction. A bit weird to think about, but yeah, reversing the string itself or the sequence of characters actually forms the effect of flipping it in a vertical direction. So yeah, that's what this does. But yeah, it's a whole load of extra code that is actually longer than the characters that was in the original regex. So I tried to make it even shorter still, thinking, well, how can I achieve this in some more concise manner? And I did manage to get it more concise with this, which I think is more concise, although it's debatable, actually. But yeah, it uses these values. So you've got four combinations of flips. I guess you've got completely unflipped board. You've got flipped in the horizontal direction. You've got flipped in the vertical direction, and you've got flipped in both the horizontal and vertical directions. Now, if you think about that, if you think of it in like a bitwise manner, if you consider the numbers 0, 1, 2, and 3, so that would be represented, if you wrote it as binary, as 0, 0, 0, 1, 1, 0, and 1, 1. So if you consider the bits, you could map those to whether or not we're flipping in a particular axis. So that's kind of the approach I tried to take with this idea. It's pretty horrible, actually, on reflection. Horrible in a kind of curious way that I'm sort of vaguely proud of it, but not like proud at all, really. I'm not sure. I'm a bit ambivalent about how I feel about it. But so we've got an array of operations here. So these correspond with function calls or method calls on the array. And yeah, as you may know, you can call a function on like an object or an array or something by using a string. So op is there, and yeah, the way I'm doing it is I'm using these 0, 1, 2, 3 values to represent the bits of those numbers to represent whether or not we're flipping in the various directions. So if you look at this, is probably a good example. So I'm doing op and then m, which is one of these numbers, 0, 1, 2, 3. Doing the modulo of m, which gives us either 0, 1, 0, and 1. So that will flip, I believe, in the horizontal direction here. And what this is doing is it's using that as an index, that 0 or 1 value as an index on this array, which means that based on these numbers, we will either slice or reverse the array. Now, if you slice the array with no other arguments, looking here that we're actually calling this as a function call, we're basically calling slice with no arguments, which returns you back the original array. Now, if it's a 1, if this resolves to a 1 here, then it's going to call, well, this would be a value of 1, and that would map to the reverse string here. So we're calling the reverse function in this particular case. So yeah, that's kind of how I'm deciding whether or not to flip the board based on these numbers. I was going for conciseness and trying to reduce the length of the solution as humanly possible. Similarly here, so this is just a way of shifting the bits to the right. So that's all we're doing here, is we're basically stripping off the right hand bit and just then considering the left bit, which means that only these two, so 2 and 3, will resolve to a value that reverses the array. So in that sense, you've got all of the 4 possible combinations for flipping in both horizontal and vertical directions. But it is longer still than the one that I posted in my original video. Now, a problem you've got when you flip it vertically is that pawns only take in one direction. So that's actually why we've got this little exclamation mark here. So you've got the C here, which is the original chessboard. And once you've got all of the characters of that entire 2x2 grid, I'm just stuffing a exclamation mark at the end, really. And when you have to match a pawn, I'm just doing dot plus and then matching an exclamation mark at the end. So if you're flipped in the vertical direction, then that would never match, because the exclamation mark would now be at the beginning of the string of text. So it would be impossible for that to match. So that's how I overcame that little part of the problem. Which brings me nicely on to my new solution. So here's the original solution, and I've modified it to reduce the padding because that's an absolutely valid suggestion. So I'm now using 2 characters of padding. In fact, to reduce the size of the solution, I'm using an integer value rather than a string because I can just pass 11, and that just gets coerced to a string of length 2. And if I have a string of length 2, you have to have the quotes, which just takes up extra space, right? It's just a ridiculous pursuit of shortness that I'm doing here. Anyway, so here's the old solution, using 11 now for padding, and you can see the new solution is shorter, 22 characters shorter. So here it is. It uses some of the concepts I've already mentioned. So this 0, 1, 2, 3 idea roughly maps to the concept I mentioned about flipping in the X and Y directions. But instead of calling slice and reverse, what I'm actually doing is I'm iterating over the positions in the board with X and Y coordinates, and I'm manipulating the X and Y values to extract the data in the order that I need. So the basic concept with this is that I've got this variable b, and I'm concatenating each character to the string to build up the string for the entire board, rather than calling like join and concatenating it all together after reversing and manipulating the array. So here I'm calculating which element in the board I want to extract. And of course, it's a 2-dimensional array. So you've got the Y coordinate, or the row, in the first position, and you've got the X coordinate in the second position. So in a very basic case, you would just have Y and you'd have X. And that would, as you iterate over, so I'm using C, I think. Yeah, I'm mapping. The only reason I'm doing that is I'm not actually using the row of data. I'm just getting the index, just because it's nice and short, and it's convenient to have this array to iterate over. Map is, by the way, the shortest method name that does the thing that I want, which is looping over C. And yeah, so you can see that if we just concatenate to this B variable, the relevant element from the 2-dimensional array, that's just going to build up the same string that we had before. But if I reintroduce all of the other stuff, well, actually, let's just go through each of the scenarios. So if I wanted to iterate with X flipped, I could do 7 minus X. So rather than going 0, 1, 2, 3, 4, 5, 6, 7, now it's going to go 7, 6, 5, 4, 3, 2, 1, 0. So it just goes in the opposite direction. And exactly the same if we did it in the Y direction. It's just going to iterate the rows in the opposite direction. So it would be flipped. So that's kind of how I started. And I ended up with this, because this now then, in a similar manner to how it was doing with calling the slice or reverse methods optionally based on these values, I'm essentially doing the exact same thing. So if I modulo 2 is truthy, then it will use X. Otherwise, it will do 7 minus X. So it will flip in the X direction. Similarly, if we strip off the rightmost bit of these values, if they were considered as binary numbers, then we would, we just control the flipping of the vertical direction. And yeah, if that's truthy, then then we of course flip the board. So finally, at the end of all that mapping, we add 99 to the end of each row. So that would be the padding so that our regular expressions work. And another notable feature is this. Now, given that we're now flipping in both the X and Y direction, we need to handle pawns quite carefully because they only take in one direction. Now, the way I've overcome that challenge is by being a bit cunning with the initial state of this B variable. So it starts out as the index of the element that we're considering. So these first two do not flip in the vertical direction, and it is only these latter two that flip in the vertical direction. So it is only for these ones that we care about pawns. And for that reason, I'm matching 0 or 1, and then any number of characters, and then followed by the match we expect for a pawn taking in a particular direction, in a particular, in a particular vertical direction. So, yeah, because we start with the initial state of this variable being the index of the array item that we're considering here, it therefore will only apply this regular expression for the first two cases where the board isn't flipped vertically. It's quite hard to explain. Now, another cool thing, now that we're orienting the board in all these various ways, it's perfectly okay for me to take the king out of all of these individual matching groups and just put it at the end. Put this in brackets so that it will choose either one of these possibilities followed by a king, because it covers all the different orientations now. And there you have it. So the final solution is 193 characters, which I think is pretty darn good. I would be impressed if it can be made substantially shorter than that. I don't know how to do that. But I can't stop thinking about trying to make it shorter. I think it is possible. But I'll let it go for now, he says, lying to himself. Well, it's the following day and I couldn't let it go. So I've managed to make it shorter by a few characters. Simply by changing the way that I'm doing this bitwise check. So doing it in this way by stripping the bits is actually not necessary. You can do a bitwise AND with the two. And that makes it a humble 188 characters in total. Finally, I did promise a teaser about my new solution, which I think is arguably as creative, if not more creative in some ways, than the previous one with Regex. So I was contemplating this problem and thinking about all of the different angles and possibilities, and I was thinking, well, what if I was the king on the chessboard? If I was actually the king looking out across the board at all these menacing pieces that are pointing themselves at me, ready to attack, and I could literally look across the board and see the pieces that are attacking me, and they would be blocking other pieces. So literally my line of sight would be blocked to the other pieces. And that got me thinking about how algorithms like the ray tracing algorithm to find like whether a particular ray hits onto a surface, the kind of thing that projects shadows in games and things like that. And, you know, it got me thinking about vectors and angles and all this sort of stuff. And I came up with the idea to express all of the pieces as vectors to the king. And in doing so, you can then filter for the relevant pieces that we're interested in. Like, do any of the pieces have a specific distance from the king? Do any of the pieces follow a particular angle to the king? So yeah, I was thinking along those lines, and I've come up with a pretty short and concise, and I think I dare say somewhat elegant solution using vectors. So I will explore that in my next video. So I hope you enjoyed this video, and I encourage you to subscribe if you haven't already. And I really enjoy hearing from all of you, and your comments are really insightful and interesting. So I would encourage you to comment as well. So until next time, see you later.